Hello everyone, welcome to my chemistry channel BL Das Short and Sweet in Chemistry. Now here I am going to explain coordination compound for the class 12 which is according to CBSE syllabus. This is part 5B, that is naming of ligands. How can you name the ligands? Before that, in part 5A I have explained what is the possible formula for the coordination compound. What are the rules for the writing of coordination compounds? And here if you say again I want to revise this one by giving some examples. Let us see, this is the coordination entity. From here to here, this is called coordination entity. And here this is actually anions, this is outer side part of the coordination entity. This is the square bracket and this charge is here plus 3, 0, so it is plus 3. And Cl3, because plus 3 there, it should be minus 3, because the complex ion, the charge, that should be balanced by the outer side ion, that is called counter ion. Now here you can see, if there are more than two ligand, more than one ligand, then what happens? They should be arranged according to alphabetic order. They named as in alphabetic order. Just like this is bromido and this is ethylene diamine, so you should know bromine come to first. Similarly here aqua A is the first, Cl is the next. So how can you name it? According to alphabetic order. If the ligand is polyatomic, that should be written in parentheses. See here, this is the parenthesis. There should be no gap. Between central metal atom and the ligands, whether it is single ligand, simple, or maybe polyatomic ligands. Now here this is E and ethylene diamine, which is an polydentate ligand, because it can donate more than one atom to electron pair to the main central metal atom. And now you can find this is cation complex. This is also cation complex. Whereas this one is anion complex. So how can you name it in organic compound? In organic compound we have seen, suppose it is potassium chloride, you should write potassium KCl. If I say barium nitrate, so Ba first, because it is cation. Similarly here also we will write first cation, that is whether it is complex or simple. Now say this is the cationic complex, and here you will write first this one and after that this one. And when you write the nomenclature, there should be no gap. Again after naming ligand we will see so many different examples of coordination compounds, so that the doubt will be clear. Now here potassium is simple one, where it acts as a cation, simple cation, and it will give the test of cation, that is K+. But here it is anionic complex, that is here minus 3. So again you can observe minus 3 plus 3 both are balanced. And similarly, if more than the ligand says there should be no gap. You will write aqua, tetra aqua, dichlorido, chromium 3 chloride. Are you clear? Aqua and chlorido, which will come first? Aqua will come first. So here tetra aqua, dichlorido, chromium 3. The 3, what you will write, that is in Roman letter and chloride, because chloride is the outer side part. It should give the acidical taste of chloride. You know what is the acidical taste of chloride? If you treat silver nitrate, then gives white precipitate. And regarding here, this is the cationic complex, this is the polydentate ligand, this is the unidentate ligand, and how many? You can see 2, so minus 2. How can you say this is minus 2 and it is plus 3, so that the cation complex charge is plus 1. And when you want to write the cationic complex or anionic complex, the charge should be written on the right side of the superscript. So here outer side bracket, you will go to up and write the charge. So this is the about what I have taught in 5A video. So when I will explain the different naming of compounds with example, at that time all doubts will be clear. Now here ligands, you know there are three types mainly. Anionic ligand is more non-neutral than positive ligands. Positive ligands are very few number. Anionic ligands, that means minus charge, and neutral the charge is 0, and positive ligand the charge is plus. So anionic ligand that ends in O, always remember, always end in O. Chloride means chlorido. Bromide, bromido. Cyanide, cyano. Isocyanide, isocyano. Oxide, oxo. Peroxide, O2 minus 2, that is peroxo. Hydroxide, OH minus, hydroxo. Sulfide, S minus 2, sulfido. Amide, NH2 minus 1, that is amido. Imide, NH minus 2, that is imido. Have you remember? Now remember anionic ligands always ends in O, so you should write O chlorido, chloride E, you delete and O write. Similarly cyanide, again cyano, IDE take out, then only cyano, isocyano, peroxo, sulfido, imido, and amido, hydroxo, like this. So I hope it is clear. Now here this metal and ligand, there is no space between them, and the charge of the complex ion and the outer side ion, which is counter ion, that should be balanced. And that means here polydentate ligands or polyatomic ions, anion, or molecules which act as a ligand, that means ligand which are polyatomic or ligands which are polydentate, they should write in parentheses. The charge one should write in the complex ion, that above the right side superscript. And these are the main points for the about naming of ligands. Again we will proceed to other naming of ligands with anions. Other anion ligands are, here you can see nitride N-3, that is known as nitrido. Phosphide P-3, phosphido. And carbonate, that is here CO3-2, carbonato. Oxalate C2O4-2, oxalato. Sulfate SO4-2, sulfato. Nitrate NO3-1, that is nitrato. Sulfide SO3-2, you should remember from the inorganic compounds formula. Then sulfito. And acetate CH3COO-1, acetato. Nitrite, that is linked with oxygen, the metal atom is linked to the oxygen. Then here, since oxygen is linked to metal atom, this is called nitrito-O. And here nitro, that means here you can say nitrogen is linked to the metal atom, so it is called nitrito-O. O means that O is linked, sorry, it is not O, this is N. Now here nitrogen is linked to the central metal atom, that is why it is called nitrito. Then here it is thiocyanate. Sulfur is linked to the central metal atom, so it is called thiocyanato S. Why? S is linked to the central metal atom. If it is isothiocyanate, N is linked to the central metal atom, so it is called isothiocyanato N. It is N. So here isothiocyanato N. Neutral molecules, that means having charge 0, and C5H5 and pyridine, that short form PY. H2O, aqua, spelling should be correct, AQUA. CO, C mean carbon, O mean oxygen, carbonyl. Ammonia, NH3, CH3, NH2, methylamine. Then nitrosyl, NO, N is nitrogen, O is oxygen, so both are capital. NH2, CH2, CH2, NH2, that means you can common name, you can say ethylene diamine or you can write ethane 1,2-diamine. Ethane, this is the house of ethane. In one position NH2 and two position NH2, so it is ethane 1,2-diamine. Positive ligands, NO2 plus. What is positive ligand? Where charge is positive. NO2 plus 1 nitronium, NO plus 1 nitrosonium, NH2 NH3 plus 1 hydrogenium, NH2 NH3 square bracket plus 1, that is hydrogenium. Again I want to recollect this one: nitride, nitrido, phosphide, phosphido, carbonate, carbonato, oxalate, oxalato, sulfate, sulfato, nitrate, nitrato, nitrato, and sulfide, that is sulfito, acetate, acetato. And then next is nitrite. If oxygen is linked, the nitrito O. If nitrogen linked to the central metal atom, nitrito N. Thiocyanate, if sulfur is attached to the central metal atom, thiocyanato sulfur. Isothiocyanate NCS minus 1, that means here isothiocyanato N. Neutral molecule C5H5N, that is called pyridine. H2O aqua, carbon CO, NH3 amine, and C3NH2 methyl amine. Then here positive ligand, NO2 plus 1 nitronium, NO plus 1 nitrosonium, NH2 NH3 whole bracket plus 1 hydrogenium. I hope the name of ligands I have completed, that is anion, neutral and positive ion ligands. So next we will see how rules of naming of ligands you will put in the coordination compounds. What are the different rules we will follow? And here I hope it is clear to you. Please subscribe my channel and share and like my channel, BL Das, short and sweet in chemistry. And also thanks for watching my video. Thanks again to all.